Yes, good afternoon, everyone. Welcome to our math class. And I am your teacher for this session. I am teacher Diane. Hope you were all doing great. So come on, let's start and study mathematics. So as we continue, let me present to you my screen first for our topic this afternoon. So we're gonna using Jamboard as our means of slides and presentation this afternoon. I'm gonna give you the link of this Jamboard on our chat box. But first, let me present. So on our Mathematics 9, we are now currently on our quarter 4, week 1. And on this topic, you're gonna have some sorts of informations about secrets. Let's have it on our next slide. So first, before we start on our main topic, let's have some motivation. And I'm gonna give you some wordles, and then you're gonna answer what wordles it is. So for our first slide, we have, and by the way, what is Wordles? Wordles is a group of pictures or letters or numbers or any representation that has a hidden meaning on it. So I'm gonna give you the answer on this one, on this example one, and then you can answer on our next slide. So we have here EKAM, EKAM written upward. So the answer in this wordles is as simply as make up, because the word make is in upward, is written in upward position. So the answer in this wordle is just make up. Got it. On our next slide, what would be the answer? So you have cycle, cycle, and cycle. Very good. You got it right. This is tricycle. On our next slide, we have HOROBOD. What would be the possible answer? Very good. The answer is Robin Hood, because Rob, the ROB, is inside HOOD, such as hood. So this is Robin Hood. How about this one? We have here lady, 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 and the first lady is underlined. What would be the possible answer? Very good, you got it right. This is first lady. Good job. Next, how about this last one? Last wordles that we have here. So, yes, come on, you can do it. Very good. Your time is up and our time is up. And now let's proceed with our discussion proper. So for our quarter for week 1, we're gonna study about on how to illustrate the 6 trigonometric ratios. And in this visual lesson, we will learn how to illustrate the 6 trigonometric ratios such as sine, cosine, tangent, secant, cosecant, and cotangent. So before we proceed on our main topic, let's have a review first. I name it. I named it. I name this activity as name my parts. So let's look on the right triangle on our presentation. What do you call to this part? Yes, it is called as the hypotenuse. Very good. And the hypotenuse is the longest side of a right triangle. Next, how about this one? Very good. It is the opposite of this right triangle. Mom, why and how come? It is the opposite of this right triangle, referring to this angle. How about this one? What would be? Yes, exactly. That is the adjacent of the right triangle. Okay, we will come up with the other, the deeper definition of this part on our next slide. But we still have a question number 4 here. What is the Pythagorean formula in simple terms? Anyone here who can still remember what is the Pythagorean theorem? Yes, so our Pythagorean theorem is equal to Pythagorean theorem, c squared is equal to a squared plus b squared. Such as c is the hypotenuse and a and b will be the sides of the angle. Let's proceed with the next slide. Okay, we still have another review part here. Given that our Pythagorean theorem formula, or in finding the other sides of the right triangle, is c squared is equal to a squared plus b squared. So again, it is c squared is equal to a squared plus b squared. Okay, for our first example, for our example number 1, we have here the um, right triangle as the sides is 3 and 4. And we are looking for its hypotenuse. So we have here c squared is equal to a squared plus b squared. Okay. Therefore, I told you a while ago that c is our hypotenuse. We can now write it as c squared, and this can be the sides of the triangle, such as 3 squared plus other side is 4 squared. And then we got it as squared of 3 is 9, squared of 4 is 16, and then we got it as c squared is equal to 25. But we are just looking for the value of c, or just the hypotenuse, and it is in squared form. So we're gonna get its root for us to be able to cancel the square, because the square root of any numbers that is in squared or in second power is equal to itself, such as it can be cancelled, and we still have here c, and then the square root of 25 is 5. Therefore, we got the hypotenuse, forgive me about my writing, our hypotenuse is equal to 5. Therefore, this is equal to 5. And what have you noticed? Yes, it is the same triangle. So therefore, our G here is 4 and our F here is 3. And if we are referring to this angle of the triangle, this would be our hypotenuse, our opposite, and our adjacent. So this is our hypotenuse, our adjacent, and our opposite. Okay? So let's now proceed with our slide 11. So suppose you were running out of time for you to be able not to late in your class. In which direction you will pass through to be in your class on time? On the way 1 or on the way 2? Just guess or give me the possible answer. Go on, go on. Okay, very good. Of course, the shortest way would be the way 1. Even though that hypotenuse is the longest side of the right triangle, if we combine the two sides, of course, the hypotenuse will be the shortest among them because it is in diagonal direction. And on this, you just need to walk through this side and walk through that side. So you better choose the way 1 for you to be not late on your class. Let's now proceed with the sides of the right triangle, what I'm talking about a while ago. So we have here the hypotenuse, or the longest side of the triangle. It is the longest side of a right triangle, the side opposite the right angle. So this is the right angle and its opposite is always the hypotenuse. The length of the hypotenuse of the right triangle can be found using Pythagorean theorem, which states that the square of the length of the hypotenuse equals to the sum of the squares of the lengths of the other two sides. There you go. How about the adjacent side? Adjacent side, it is the leg of the right triangle where it is side next to the given angle. In this example, this is your given angle or your given theta A. Of course, the side beside this angle, we can call it as the adjacent angle. And for the opposite angle, it is on the opposite side of the given angle. So again, hypotenuse, longest side, adjacent, the side next to the given angle, and then the opposite side is the side opposite to the given angle. Let's proceed with our slide number 13. Okay. On our slide number 13, we have here the problem. So in problem number 1 or our example number 1, what is the length of the side opposite angle X and the length of the side adjacent to angle X? So we are referring to the angle X. So this is your angle X, okay? So the question is, what is the side opposite this angle? So this is the opposite angle. Therefore, the length is 3. And its adjacent or the next on the next side of the angle is the 4. Therefore, the adjacent side is 4. So, as easy as that. Just get the value of the opposite side and then the adjacent side. And we have here a note that we need to keep in mind that the labels opposite and the adjacent depend on which angle you are talking about. The side opposite an angle does not need to be the height of the triangle. Consider the following example, like this. So what does it tell? The opposite and the adjacent side always referring based on the given angle. So in this example, this is the given angle, therefore this is the opposite and this is the opposite and this is the adjacent. But ma'am, what if? What if you are referring to y angle? What would be your opposite? Your opposite would be 4 and your adjacent would be 3. Okay, good. Next, on our example number 2. What is the name of the side opposite the 40 degrees angle? And the name of the side adjacent to the 40 degrees angle. So we are referring to this 40-degree angle. So what is the opposite side? We are looking for the side, not for the measurement of the sides. So we are looking for the side opposite to 40 degrees. So opposite to 40 degrees is side PR. So this is the PR. So opposite to the 40 degrees is the side PR. And then the adjacent for the 40 degrees is this side, such as QR. Okay, so this is the opposite side, PR, and then the adjacent side is QR. Next slide. Okay, let's proceed with the 6 trigonometric ratios and how you will come up with the proper renaming of the 6 trigonometric ratios. So, given that our theta here is angle A. So, for the sine, always remember the short term. So, ka, to, wa. So, if you remember this simple term, the SOHCAHTOA, you can now easily illustrate the 6 trigonometric functions. Ma'am, how and why? Why does it is very helpful, the word SOHCAHTOA? So, this is the reason why. Because S is referring to sine or the SINE. C is for cosine, and T is for tangent. O is for opposite, H for hypotenuse, A for adjacent, A for hypotenuse, and O and A is opposite and adjacent. So as simply as if you are referring to sine A, such as this theta, it is also equal to opposite over hypotenuse. Opposite over hypotenuse. So remember the word so. So, S-O-H. Because sine is equal to opposite over hypotenuse. Next, for cosine, it is ka. Ka. Cosine, adjacent, hypotenuse. So we have your cosine, and it is equal to adjacent over the hypotenuse. Next, for tangent, we have here towa. Towa. So we have here opposite over adjacent. So if you remember or you mastered SOHCAHTOA, you can now come up with its reverse or the reciprocate of this term, such as cosecant, secant, and cotangent. Sine, cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. So if we are talking about the reciprocal of any term, the simplest explanation would be um, just exchange your denominator to numerator. So as easy as if you are looking for sine and its reciprocal is cosecant, and sine is equal to opposite over hypotenuse. Therefore, cosecant is equal to hypotenuse over opposite. So as simply as the short term is just the word kabaliktaran in Tagalog. So pagbabaliktarin lang natin siya. Next, the second is the reciprocal of cosine. Therefore, we have here secant is equal to hypotenuse over adjacent. Hypotenuse over adjacent. So as easy as that. And for the cotangent, it is cotangent adjacent over opposite. Cotangent adjacent over opposite. So that's it. That's that's how you can easily remember the 6 trigonometric functions. There are 6 ratios that you can compute, such as cos, tan, cot, cotangent, secant, and cosecant. So just as sine is an abbreviation for the sine, cos is the short for cosine, tan is the short for tangent, cosecant is the short for cosecant, sec is the short for secant, and the cot is the short for cotangent. When reading this abbreviation aloud, you need to say the complete word. So even though it is just CSC, we will read that as cosecant. Even though it is just sec, we will read it as secant. So tip. The 6 trigonometric functions will help you to find the unknown length and the unknown angle measures in the right triangle. Next, for our example number 3. So we have here the right triangle. And this is your angle. So determine the 6 trigonometric ratios for an angle in the right triangle. So we have here the opposite is 4. The adjacent is 3, this one. And then the opposite, the hypotenuse is 5. So the first thing you need to do is to recognize the length and write down their lengths. So we have here the 6 trigonometric functions, the sine, cosine, tangent, cosecant, secant, and cotangent, referring to the angle D. So we said a while ago that sine is equal to opposite over hypotenuse. What is your opposite? Your opposite here is 4, and your 4 is your opposite, and your yes, and your hypotenuse is 5, and your adjacent is 3. Okay, there you go. So you cannot easily write the 6 trigonometric functions. So for our sine D, your opposite is 4, and your hypotenuse is 5. Okay, and then the cosine. Again, what is cosine? Cosine is equal to C-O-H. So your O, or your opposite, is 4, and your hypotenuse, so I'm sorry. So letter A, adjacent. So this is 3, and over 5. And for your tangent D is equal to TOA, opposite over hypotenuse. So your opposite is 4, and your adjacent is 3. And again, its reverse, or yung kabaliktaran, I told it a while ago, is the cosecant, the secant, and then the cotangent. Of course, we are referring to D, angle D. I'm sorry about my writings, ha. I don't have mechanical mouse. Okay. So for cosecant T is just the reverse of it. What is the reverse or the reciprocal? Sorry, not the reverse. Sorry for my term. The reciprocal is 5 over 4. For the cosecant, the reciprocal is 5 over 3. And then the cotangent, the reciprocal is 3/4. Okay, so there you go. We got here the 6 trigonometric functions. And also, improper fractions is acceptable in writing the 6 trigonometric functions. So no need to rewrite it on the mixed number or the proper fraction. So, any question on how to get the 6 trigonometric functions? Very good. So let's now proceed with our example number 4. Determine the 6 trigonometric ratios for angle E in the right triangle given in example number 3. So for our example number 3, we just need to write the 6 trigonometric functions. So I think we got here. Sorry. But in this case, we are now referring to angle E. So this is now the angle E. Okay? So since we are now referring to angle E, your hypotenuse here is still the H, the 5. Your adjacent here would be the 4. And your opposite here is the 3. So getting its 6 trigonometric functions, we have here sine E, cosine E, and then tan E. And its reciprocal, the cosecant E, the second E, and then the cotangent E. Okay, so we got it right. So all we need to do is just to find the 6 trigonometric ratios. So for the sine, it is opposite over hypotenuse. So what is your opposite here? Your opposite here is 3 and your hypotenuse is 5. Okay. For your cosine, it is ka, adjacent over hypotenuse. And your adjacent is equal to 4 and your hypotenuse is equal to 5. Very good. Next, for our tangent. For our tangent, it is TOA or AO over A. Such as opposite here is 3 and your adjacent here is 4. And its reciprocal, your cosecant will be 5 over 3. Secant will be 5 over 4. And your cotangent is 4 over 3. Okay, so we got now the 6 trigonometric ratios. So sine is the reciprocal of cosecant, cosine is the reciprocal of secant, and tangent is the reciprocal of cotangent. So as easy as that in illustrating and getting the 6 trigonometric ratios. Next, we can now conclude, so as easy as that. So what if, ma'am, the other side of the right triangle is not available? So you need to answer it first, get the side of it using Pythagorean theorem, and proceed with the given 6 trigonometric ratios. So you can now, little by little, you can now come up and completed the sides. And if the sides is already complete, of course, you can easily write the 6 trigonometric ratios. So we now conclude that cosecant, secant, cotangent are the reciprocal of sine, cosine, and tangent respectively. And these are the 6 trigonometric ratios. So let's have some practice here. So determine the 6 trigonometric ratios for angle B in the right triangle. This is what I'm talking about. So in this case, hypotenuse is missing. So hypotenuse is missing. And we are referring to angle B. So in angle B, this is the adjacent. And in this angle B, this is your opposite. So I will answer this problem number 1. And of course, the next problem, you will answer it on your own for you to be able to practice if you got our lesson. So since, again, I will always remind you if there is a missing part in the right triangle, you need to find it first using the Pythagorean theorem. So in this case, again, what is the Pythagorean theorem? Very good. So this is equal to c squared is equal to a squared plus b squared. Okay. And then we are looking for the hypotenuse. Your sides are 6 squared and 8 squared. And then c squared is equal to 6 times 6, 36. 8 times 8, 64. And then we have here c squared is equal to, can you please help me? Huh? 100? 100? Is that 100? Okay, 100. Very good. And then 100 is for a while. Let me check my calculator if it's correct. Of course. We will just sorry, 6 times 6 is equal to 36 and 8 times 8 is equal to I'm sorry, what's that? 8 times 8 is equal to 64. And 36 plus 64 is equal to 100. And its square is 10 exactly. So as simply as that. So in this case, using calculator is allowed, of course. So c squared, it's reciprocal. Sorry, reciprocal. I'm sorry about my term. It's square root. For us to cancel this square on our hypotenuse is equal to 10. Therefore, our h or our side AB, or we can write it also as side C, small letter C. Okay. So in this case, our hypotenuse is 10. So we are now complete with the sides of the right triangle. Since we are complete, we can now answer the 6 trigonometric functions. Go on. Answer the 6 trigonometric functions. Okay. So for our solution, this is our solution. And for our sine or let me rewrite it na. Sine B cosine B and then tangent B is equal to sine. Opposite over hypotenuse. What is my opposite here? My opposite here it is 8 over my hypotenuse is 10. So what have you noticed? It is not in simplest form or it is not yet in lowest term. So we can rewrite it on its lowest term. So this is 4 over 5. Okay. 4 over 5. And for our cosine, it is ka. So ka, C-A-H. So your adjacent here is 6. And your hypotenuse is 10. And its lowest term is 3/5. For our tangent, it is towa. Opposite over adjacent. So it is 8 over 6 or 4 over 3. Very good. So for our cosecant, secant, and cotangent. Of course, we are referring to side B. Don't forget. Because it is very important to write the angle. So its reciprocal, 5 over 4. Second is 5 over 3. And cotangent is 3/4. There we go. We now completed the 6 trigonometric functions, even if the other side is missing. So, as easy as that. And for our last slide on this Jamboard, hope you understand on how to illustrate the 6 trigonometric functions, because it will be very important in our preceding topics, such as solving the right triangle. In solving the right triangle, the 6 trigonometric functions is very important. So please practice yourself. If you're still confused on how to get the 6 trigonometric functions. And for our generalization, let me just read it to you. So there are 6 trigonometric ratios such as sine, cosine, tangent, and its reciprocal, cosecant, secant, and cotangent. These 6 trigonometric ratios are abbreviated as sine, cosine, tan, cosecant, secant, and cotangent. These are referred to as ratios since they can be expressed in terms of sides of right triangles, right angle triangle for a specific given angle theta. So, for our generalization, can you please help me to answer the appropriate um, value of the 6 trigonometric functions? So, sine, it is what? So, or it is equal to opposite over the hypotenuse. And of course, its reciprocal is hypotenuse over opposite or the cosecant. For cosine, its reciprocal, um, it is equal to adjacent over the hypotenuse or the Cah, C-A-H. And its secant, its reciprocal, it is hypotenuse over adjacent. And for tangent, the TOA, T-O-H, it is opposite over adjacent. And its reciprocal, cotangent, it is adjacent over the hypotenuse. So remember the word so ka tawa, because it will be very helpful for you to remember the 6 trigonometric ratios. Okay, now we are done with our Jamboard. Let us appreciate what would be the use of these 6 trigonometric functions. So there is a 5 uses of the functions in real life, such as it is used in finding weather and climate patterns. Oh yes, that's true. 2. GPS and cell phones relies on formulas involving sines and cosines. Number 3. TVs and radios involve sine and cosine waves to transmit images and sounds. So let us just appreciate what would be the uses of this trigos in real life. Next, it is used in oceanography to calculate the height of tides in oceans. And submarines use radars that use sign to monitor things under the sea. So it is very useful in our real life situation. So I have here 2 questions for you to be able to appreciate it in your own. So my first question is, do you agree that, that trigonometric ratios are essential in our daily living? So answer it. Justify your answer. Limit your answer in 3 to 5 sentences. And my other question is, give at least 2 examples of your daily activities that will useful for trigonometric ratios. And give me your answer on the comment sections. On You can do PMs to answer this and give some feedbacks on our video lessons. For our evaluation, practice this, answer it on your own. For our directions, answer the following problem, show your illustration and complete your solution, given that having the complete your solution. So number one is to find the 6 trigonometric functions of this sample. And number two, three, four, just read with understanding and answer it with complete illustration and solution. And for your assignment, answer this on a separate sheet of paper. So, how's our video lesson about illustrating the 6 trigonometric ratios? Thank you so much for listening. Thank you, class, and thank you for the support. You can rewatch this video lesson on my YouTube channel, Teacher Magandayan, Magandayane, for you to be able to replay on the part that you got confused. So, no more question? That's all for this session. See you next time. Have a good day. Stay safe. Stay clean. God bless. Bye.